All right, this is chapter 13 on mineral and rock resources. And I'm calling this first section where things come from. So here's like really a whole list of vocab words, but resources are the things that we need to live. So any material necessary to human life and civilization. Reserves is the amount of that material that has been found and is recoverable economically with existing technology. That's reserves. Then there are cumulative or no, conditional reserves. That is, we have found it, we know how much is there, but it's not currently economical, or we can't get it with our current technology. It's just not possible. Maybe it's too deep or it's way down in the bottom of the ocean. We don't know how to get there. Things like that. Cumulative reserves are what is left in the ground that we haven't mined yet, plus what we've already mined. So what was originally in place. Sub-economic resources, those are the conditional ones I just talked about. They've been found. We just can't get to them right now, either literally because we're limited, or economically, if you were to mine it, you would lose money. So nobody's going to go do that. It would cost you more to mine it out than you could sell it for. Hypothetical and speculative resources are ones that haven't been discovered yet, that for some reason we think there's a good chance that there is some amount of this material in that area, just given known geologic relationships, or maybe there are other deposits nearby that make us think that it's likely there. Ore deposits. An ore is a rock with a valuable or useful metal that occurs and is economic to mine. The concentration factor, kind of how you measure is how much of that element or mineral is in the ore, is this equation here. So that's the concentration of the metal in the ore divided by the concentration of the metal of your average rock in the continental crust. So if you think you found an ore and it has the same amount as the average rock in the continental crust, it would be one. If it has less, it would be a fraction. And if it's greater than that, you would have bigger and bigger numbers. So the higher the concentration factor, the richer the ore is. The cost factors, the cost of mining it depends on not only how much it is and how concentrated it is. Obviously, if you have something really, really concentrated, you don't have to process it as much. So versus something that's like the rare earth elements, they're actually everywhere, but they're really, really like very diluted with other elements in the rock, so very, very hard to process. Um, and the demand has a lot to do on that. They call it the energy cost going. I mean, these like mining equipment use gas and stuff, those big bulldozers and whatnot. Then there's the cost of paying your workers. There's the cost of transporting it to either where you're selling it or where you're going to need to process it. And as well, there's the environmental cost, the cost of remediation or preventing like acid line drainage. Um, Here is a chart showing how by mineral or by element, these are all elements, by element, what countries they're mostly in. And you can see the US, it's pink. We really don't have that much. The one we have the most of is the one I can't pronounce, molybdenum. I don't know, that one. Then we have some nickel, lithium, copper, and a very little tiny bit of cobalt and iron. Other countries have much larger portions, but you don't find it's not like South Africa has a lot of platinum, but South Africa doesn't have a lot of the rare earth elements or the nickel, so it's going to change. What are the different types of mineral deposits? So starting with igneous, you think, I think igneous and metal. Um, we have it concentrates through pretty much through hydrothermal or magmatic differentiation. So in a magma chamber, the denser minerals and elements are going to settle to the bottom. This is, kind of liquid, not quite like water, but still liquid enough they can settle down to the bottom. If they're light minerals, they're going to float up on top. And so then they differentiate themselves and concentrate themselves so that when the magma chamber cools and we're able to go get them, we can kind of hone in on mining that part of the chamber and what we're interested in. There's also hydrothermal fluids. This is water that comes in through the pores um, and permeability of the rock. It gets really, really heated when it gets next to the magma chamber. And as it gets really hot, it's able to dissolve a lot of the minerals and things out of the host rock, being just the bedrock it's in. Um, and then when it cools off, then everything it had dissolved precipitates out and forms crystals. Not necessarily crystals like you think of, but it forms a solid. Um, Here's a picture of some of that, of the veining. So we call these veins. Um, so these are hydrothermal deposits here, and then here's a diagram showing how that would work in your uh, rifting at your um, ocean spreading ridges. There's a black smoker, so again, the water from the ocean creeps in through cracks and pores and things, gets really, really hot. And as it gets really hot, it's leaching out all of the, not all, but a lot of the elements and minerals out and comes up, and then it deposits it in, like I said, chimney deposits. Here's pegmatite. These are igneous rocks where it cooled so, so very slowly that the crystals got to be very, very, very large. So again, then it's really concentrated and becomes more economical. Kimberlite is the type of rock that we find diamonds in. Hydrothermal ores, that's what I just talked about, found in veins. And then we do see a relationship to plate margins. So obviously you're going to see these igneous related deposits where you're going to find magma chambers, and that's either going to be in your rift zones or by your subduction zones. And that's shown here. So you can see a lot of mining locations along the subduction zone. Now, it doesn't have to be current subduction zones. It could be places that were subduction zones millions of years ago. Um, but it still would have been near that magma chamber. And if nobody's mined it yet, it's still going to be there. Unless it's weathered away, and we'll get to that in sedimentary. And then here we have a lot you can see in Nevada, and that's because that's a rifting zone. So again, it's been near a lot of magma. Types of sedimentary mineral deposits. So here we have banded iron. This kind of formed almost at one time as oxygen became more abundant in our atmosphere. Rust is FeO3, so iron and oxygen. And it precipitated out of solution kind of all over the oceans everywhere. At least that's what we think right now. So we get iron mostly from the banded iron formations because it's very economical to get it from this source. And here's an example of rock salt, which is an evaporite, which is it dissolves in water. I'm sure everybody knows, salt dissolves in water. And then if you evaporate the water out, then the salt reprecipitates and you have the salt again. And so you'll find it in places where water bodies have evaporated, like inland seas, lakes, and things like that. Very common in desert environments that might get a lot of like rain and flooding in the winter, and then everything dries up in the summer. Placers. This is where it's been weathered. So, uh, it rains, weathering processes pick up these materials. This is very common with gold, but there are other ones too. But you think of like the gold panning out west, this is kind of a big part of it. So the gold would get found, it would come into these streams. And so there's gold up here somewhere, and it's being washed down piece by piece. And so the miners would either go and they do their like gold panning and find it and then go this stream here. And then they would come back up and follow up the stream to see if they couldn't find like the major source. Those that couldn't find the major source could look for these old placer deposits, which is where the river sediments are just being deposited. And since there was so much, you can just think of like the gold was like a gold pebble in the river floating down, like all the other ones. You had granite and feldspar and all these other rock types, and gold was one of them. And it would be deposited like everything else on these gravel banks. So here you have just like a water slide. Where it curves, the water is going to go to one side or the other. If you think of going down a water slide, you know, it turns and you go over to one side and you go up real high, and then it turns the other way and you go up the other side real high. Same thing's happening here. And so it's eroding the bedrock and the soil from where it's going up high and hitting that edge. The other side, it's depositing its bed load, which is just the stuff that's floating in the water. And so where you have the deposited bed load here, these gravel banks, you could find gold or whatever you might be looking for. And it doesn't have to be just like the subduction zones. It doesn't have to be a current river. It could be an old river, and a lot of rivers change course throughout their lifetime. So maybe if it's not even an old river, maybe the river at one point flowed this way before it found an easier path here. Then you could go over here and look for these placer deposits where those banks, river banks are. And then here's just a picture of it being mined. And then this just kind of lists there are metamorphic deposits too that we go after, like graphite, asbestos, and garnet. Here are some, metal. So some examples of metals are iron, aluminum, copper, lead, zinc, nickel, cobalt, gold, silver, platinum. Metallic minerals, we have sulfur, lime, which is calcium carbonate, or halite, which is the salt, clay, gypsum. And then rock resources, our limestone, our sand, our marble, granite, things like that. And that is it for where things came from.